Now I want to talk about drag and terminal velocity. The most important factor that affects this, drag and terminal velocity, is friction. Now friction is a force that opposes motion. There are two main types of friction. There is friction between solid surfaces and there is fluid friction, which is also known as drag or fluid resistance, or we know it as air resistance. Now when we talk about a fluid, this can be a liquid or a gas. So there can both be fluids, liquid or a gas. Now there are a number of rules with regarding drag, number of rules. First of all, the force from the drag is proportional on the thickness or viscosity of the fluid. If you double the viscosity, it will double the drag. The friction or drag increases as the speed increases. And thirdly, the drag will depend on the shape of the object. The larger the area pushing against the fluid, the greater the resistant forces. Now it's important to remember that the drag forces always act in the opposite direction to the motion. They can never speed anything up. They can only slow it down. So drag forces can only slow things down. They can never ever, they can't speed them up. And finally, they convert kinetic energy of motion into heat energy. So when you've got drag, like a drag or air resistance, what that's actually doing is the energy is being converted into heat energy. So when you open a parachute and you get the drag forces, there's heat being created due to the drag forces. Now the next expression I want to discuss is terminal velocity. What you'll find is that things in motion will eventually reach a point where they will not go any faster. And this point is called terminal velocity. Look at here, stage one. A car accelerates from standing, so there's a driving force pushing it forward. And the result is forward motion. So you put the accelerator down, you will start to accelerate. Stage two, as the velocity increases, the resistance forces increases due to turbulence. And this reduces the actual acceleration of the vehicle. So the faster you go, the more the drag forces are. Stage three, a point is reached now where the driving force is the same as the frictional force, and therefore the velocity will have reached its terminal velocity. In other words, what you find is your car will not go any faster. So you put your foot on the accelerator, when it gets to a certain speed, if you notice, it stops unless you accelerate more, and now it stops, and that's reached its terminal velocity. It does not accelerate anymore, and the resultant force is zero. So it's still travelling at a certain speed, but it's not accelerating. The principle of this terminal velocity can be shown in a graph, as you can see here. This clearly shows that velocity will initially increase in the early stages, and then it plateaus off as the frictional forces increase to reduce the impact of the driving force. And eventually there comes the point where the frictional force equals the driving force, and the velocity remains the same. So don't forget, as you're increasing it, the drag resistance is increasing, and it comes out, balances out. That's now terminal velocity. Now this graph here shows you the same impact on the acceleration of a moving vehicle. So this is now acceleration. As you can see, as the driving force is applied, the vehicle will start to accelerate. Now this acceleration will immediately start to reduce as the frictional forces increase. In other words, as you start getting faster, the frictional forces increase. So the acceleration is dropping down there, as you can see, and eventually the acceleration stops. And at that point, when the frictional force is equal to the driving force, the acceleration will cease and the vehicle has reached its terminal velocity, as you can see there, terminal velocity.